Copy that, ELCOM. All systems are go for entry, descent, landing. Stand by. Stand by.
At the dawn of the 21st century, space agencies in Europe and America began making plans to land the first humans on Mars. But manned missions to the Red Planet have been proposed before. For some, Mars holds the answers to mankind's future in space. Others say Mars is too far, too dangerous, and too expensive for humans to explore. And in a world torn by troubles, some say there is no need, or will, for mankind to reach into space anymore. More than 30 years after the last Apollo astronaut walked on the moon, the American manned space program seems to have lost its way, unable to reach beyond even low Earth orbit.
We've got a problem. NASA has been literally going around in circles with its space program for the past 30 years.
Astronautical engineer Dr. Robert Zubrin has been arguing for years that sending humans to Mars is the mission the space program needs.
It's time that we set goals for NASA that were worthy of the risks of human spaceflight. Mars is the next logical step in our space program. It's the challenge that's been staring us in the face for the past 30 years. It's the planet that's most likely Earth. It's the planet that has on it the resources needed to support life and therefore someday technological civilization. It's the planet that will provide us with the answer as to whether life is prevalent in the universe or exclusive to the Earth. And it's the planet that will give us the critical test as to whether humanity can break out of the planet of our birth and become a spacefaring species.
In the early 1990s, Zubrin was the head of the Mars Direct program at Martin Marietta Astronautics. His team developed a mission to Mars that could be done at a fraction of NASA's projected costs. Using only existing technology, Zubrin argues that the first steps on Martian soil could be made within 10 years.
There is absolutely nothing in this that is beyond our technology.
We are not ready to send humans to Mars right now. We don't know how to keep them alive. There are people out there who say we can go to Mars tomorrow. One of my requirements, one of NASA's requirements, is that if we send humans to Mars, we bring them back alive.
For the past 15 years, Zubrin and his colleagues have waged a campaign to convince society and the political class that humans on Mars should be the goal for NASA now. This is the story of our cold neighboring planet and the debate over whether man's fate is tied to the red world. It's the story of an engineer's journey and the battle of ideas over which direction in space will truly benefit mankind.
We're at a crossroads today. We either muster the courage to go or we risk the possibility of stagnation and decay.
The victor in this debate could determine the fate of mankind. Will we become a spacefaring species? Will we live on more than one planet?
In the winter of 2003, the Chinese put their first taikonaut in space. The Chinese Space Administration plans to begin a manned program of moon exploration by 2017. The European Space Agency has outlined a plan for humans to the moon by 2024 and to Mars by 2033. And the Russians, building on years of experience, are conducting tests for long-duration Mars missions. In America, with the impending retirement of the shuttle fleet and the completion of the International Space Station, the Bush administration announced in 2004 the Constellation Program,
on the moon,
a plan that would return Americans to the moon by 2020. But the program was never fully funded and was eventually cancelled. In 2010, the Obama administration announced its vision for NASA and human Mars exploration.
By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow, and I expect to be around to see it.
With a new timeline for humans to Mars sometime after 2035, and with administrations changing every 4 or 8 years, it is far from certain that such a plan will be realized. 20 years earlier, the first President Bush also proposed a long-term human exploration program, under great fanfare. The program quietly died in Congress a few years later.
If you want to go to Mars, you cannot do it in 30 years. You can't do it in 20 years. You've got to do it in 10 years or less when programs start, or you're more or less guaranteeing political failure.
To date, only the Apollo moon program, which was announced in 1961 and had men on the moon 8 years later, has succeeded in getting astronauts beyond low Earth orbit.
I was 5 when Sputnik flew. And while to the adults, Sputnik was a terrifying event, to me, as a child who was already reading science fiction, it was exhilarating, because it meant that this possibility of a spacefaring future was going to be real. And I was 9 when Kennedy gave his speech committing us to the moon.
To go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
I grew up during the 60s when it was Mercury, it was Gemini, it was Apollo. Every month, NASA was doing something more impressive than in the month before. We were going to be on the moon by 1970, Mars by 1980, Saturn by 1990, Alpha Centauri by the year 2000. We were moving out, and I wanted to be part of that. And so I got myself a scientific education. But then, in the early 70s, it's all collapsed. We achieved the first part of that program, moon by 1970, but the Nixon administration shut down the rest, and we did not move out into space. And for a while, I accepted that, grudgingly. I became a science teacher. But then in the early 80s, something hit me, and I said, I'm not going to accept myself doing less than what I had dreamed of doing when I was a boy.
Zubrin went back to graduate school, getting advanced degrees in engineering and aerospace. He then went on to work at Martin Marietta, which later became Lockheed Martin, designing interplanetary missions. It was here that Zubrin's obsession with the Red Planet began to take hold. While at Martin in the 1990s, Zubrin and his colleagues developed a plan for sending humans to Mars that changed NASA's thinking on the issue. But the plan has languished on the drawing boards ever since. Now, as president of the Mars Society, Zubrin is at center stage in the debate over the future of manned spaceflight. Known as a smart, visionary scientist, he has authored several books on exploring space and is the self-appointed spokesman for the possibility of colonizing Mars.
Mars is where the future is. Mars is the closest planet to the Earth that has on it all the resources needed to support life and therefore technological civilization. It has water, it has carbon, it has nitrogen, it has a 24-hour day, it has a complex geological history that has created mineral ore, it has sources of geothermal energy. Mars is a place we can settle.
One reason for such optimism over a frozen world like Mars is evidence that 2 billion years ago, Mars was a much warmer and wetter place.
We think that at one time in the ancient past, Mars was very similar to the condition of early Earth.
This Martian warm age lasted for over 1 billion years and could have been a suitable environment for the development of life.
If we go to Mars and find evidence of a second genesis on Mars, I think we can conclude that the universe is full of life. We can probably conclude that on some planets that life evolves to more complex forms, and I think we'd be reasonable to conclude that intelligence could also emerge on some planets as well. It really does answer the question, are we alone? And that to me is a question that transcends science. It's a philosophical, societal, as well as scientific question. To me, that's the big prize. That's why Mars is interesting. That's why human exploration makes sense.
Space programs are often criticized for the huge sums of money they require. Although the American space program is less than 1% of the federal budget, a human mission to Mars may have to wait for better times.
There are those who say that we have many problems to deal with here on Earth, and we need to postpone ventures such as the human exploration on Mars until these problems are solved. Well, there were many problems in Spain in 1492, and there still are. There are problems that need to be dealt with here on Earth, and should be dealt with. But we also have to think of the future. We also have to think about opening up new volumes in human history. I believe that it's essential for a positive human future that humanity expand into space. The greatest value that we got out of Apollo was the creation of intellectual capital through the inspiring of millions to go into science and engineering to be part of the great adventure of human expansion into space.
There's a phrase that happened with the Apollo program, which was, if we can go to the moon, we can. And then everybody's filled in whatever they were interested in. Build mass transit, cure cancer, do this, do that. The point is, it did give us a sense that we could accomplish great things. It did bring out the best of us.
We excited a generation of engineers and scientists. The generation that built the computers and cell phones and all the technology everybody uses today and takes for granted.
If we set humans to Mars as our goal, we'll get millions of new scientists that will create new inventions, new industries. This is the enormous payback, and we can get it if we set the kind of challenge that will inspire the youth.
To Zubrin, civilizations, like people, thrive on challenge and decay without it.
We have everything we have today because of our predecessors who had the courage to leave the world of the known and go out into the wilderness and build new cities. And if we stop being people like that, then we will hand down much less to our posterity than our ancestors handed down to us. So there's the choice in life. One either grows or one decays. Grow or die. I think we should grow.
History proves that we have never lost by pressing the limits of our frontier.
In the summer of 1989, the first President Bush announced the Space Exploration Initiative, directing NASA to draw up long-term plans to get humans back to the moon and begin developing a program of manned Mars exploration. At Martin Marietta, Zubrin and his colleagues looked forward to moving NASA's space program outwards after 2 decades in low Earth orbit.
Of course, we were very excited when Bush made his call saying that he was making a national commitment to implement such a program.
NASA assembled a large team to take on the space initiative. In 90 days, the team developed a 30-year plan that required an enormous buildup of space infrastructure.
What the NASA bureaucracy decided to do was basically design the most complex mission they possibly could in order to make sure that everyone's pet technology would remain mission critical, which is the exact opposite of the correct way to do engineering.
First, NASA would triple the size of the planned space station and add enormous hangars, as well as free-floating fuel depots, checkout docks, and crew stations. Then, on the moon, they would construct more shipbuilding facilities, bases, and depots. Next, the moon crew would construct the Mars ship, a huge craft dubbed by its detractors as Battlestar Galactica. This ship would carry everything to Mars over an 18-month flight. Once in Mars orbit, a small group would descend to the surface, spend a few days, then plant a flag in the ground and go home. The plan became known as the 90-day report.
To those of us at Martin who had been engaged in designing Mars missions, when they saw the monstrosity of complexity of the 90-day report, we were dismayed, and it was readily apparent to anyone with any insight that that program would fail politically.
The plan was submitted to Congress. The estimated cost, $450 billion. The legislators went into sticker shock. This would have been the single most expensive program for the United States since World War II. By the end of 1990, Congress had refused all requests for SEI funding. When the realization came that SEI was doomed, Zubrin wrote a memo to his colleagues at Martin Marietta, outlining his problems with the NASA plan and arguing for a more direct approach. Zubrin favored launching a Mars mission directly from the surface of Earth, using only existing rocket technology. This negated the need for a lunar base and avoided the complexity and cost of building ships in space. He also objected to NASA's plan for a short surface stay on Mars, a mission that would amount to little more than a flag and footprints exercise. To Zubrin, we were going to Mars to explore and develop a new world. To maximize surface time, Zubrin proposed using a faster flight path, known as a conjunction-class mission. This would mean a crew could arrive on Mars after only a 6-month journey. They would then remain on the Martian surface for a year and a half. This would give the team time to explore a wide area and conduct detailed research about the planet. Then, as the Earth return window opens, the crew would launch from Mars for the 6-month trip home. Zubrin was convinced that a simplified, more robust and cost-effective mission could be designed using these principles. Along with several like-minded colleagues, Zubrin decided to ask management at Martin to allow them to design alternative Mars missions.
The management approved that, and we formed a team that was known as the Scenario Development Team of just 12 people from the whole very large Martin company.
One team member, whose thinking was closely aligned with Zubrin's, was David Baker.
I went off to my office and said, all right, how would I do a Mars mission if I had to pay for it and I had to go on the ride? And I said, well, it's going to be simple. There's going to be no on-orbit assembly. I really tried to take everything out of the mission that didn't absolutely need to be there.
While the rest of the team focused on longer-term, more traditional mission plans that required on-orbit assembly, Zubrin and Baker decided to collaborate on a mission that could be done near-term.
We decided to do Mars the way Lewis and Clark did America. Okay? Use local resources, travel light, live off the land.
Zubrin and Baker were convinced that a Mars mission could be launched directly from the ground. The other team members felt this was impossible, that the weight of the rocket fuel required for a round trip to Mars was so enormous it would render the launch ship impossibly heavy. To solve this problem, Zubrin was exploring a radical idea that had been kicked around the aerospace industry since the 1970s. The idea was to produce a methane-oxygen rocket fuel directly from the Martian atmosphere. It was a relatively simple and robust chemical engineering procedure that was done commonly in the 1800s, the era of the gaslight. If the idea worked, astronauts could land a relatively light ship with empty tanks. They wouldn't have to ship all the fuel with them for their return trip. This would radically lower their size and weight. The only problem was methane-oxygen fuel requires a hydrogen component. Hydrogen exists on Mars in the form of H2O, but water may be difficult or impossible to extract from the Martian environment.
Really, the hydrogen was only 5% of the total weight of the methane-oxygen propellant being manufactured. So if you just say, okay, we won't be pure, we won't get all of the propellant from Mars, we'll just get 95% of the propellant from Mars. The other 5%, the hydrogen, we'll just bring from Earth.
Another fundamental resource that could be extracted from the Martian environment is oxygen. A second processing unit could separate oxygen molecules from the thin carbon dioxide atmosphere, providing breathable air for a Mars crew.
If used intelligently, the same resources that make Mars interesting are precisely what could make it attainable.
Baker and Zubrin had greatly reduced their mission mass, but they still found their ship was too heavy and would require 2 launches and assembly in space. Then Zubrin hit on an idea.
Well, one of the key events of the Mars Direct development was one morning Bob burst in my office and said, "I've got it."
The idea that I finally hit on in 1989 was that we would split the mission up into 2 parts, and we'd send the return vehicle out first with its own return propellant plant. So the propellant would be made on Mars before the first astronauts ever left Earth.
With 2 separate direct-to-Mars launches, a human crew would have a fully fueled ship waiting for them on the surface of Mars before they ever left Earth. So Zubrin and Baker had come up with a plan that seemed to accomplish all of their goals. It was relatively inexpensive, development time was short, they could use existing technology, and it allowed for a long stay on the Martian surface. They dubbed their idea Mars Direct.
SSC disconnect enable on. 35. Let guys go. Hydraulics go.
Aboard an Ares rocket is the Earth Return Vehicle, or ERV. No one is aboard this ship. It will pave the way for the astronauts who, years later, will use the ERV to return to Earth.
1. And liftoff.
On its second day, the ERV deploys a small nuclear power reactor. The reactor powers a chemical plant inside the ERV. the plant will produce the methane-oxygen rocket fuel for the launch home. Nearby, a second robotic rover is guided to a pre-picked landing site for the human crew. It places a radar transponder to help guide the astronauts in. The long journey to land a human being on Mars begins.
3, 2, 1, engine start.
Carrying the most skillfully assembled flight team in history, 4 astronauts begin their 2.5-year mission to the Red Planet. This will be the first time a human has gone beyond the Earth-Moon system, 250 million miles farther than any person has ever been. To counter the health problems of zero gravity and to fully acclimate the astronauts to Mars, the ship will deploy a weighted tether attached to the last stage of the spent rocket booster. By thrusting the ship into a rotational spin, the counterweight of the rocket will create centrifugal force and thus artificial gravity. The crew will be able to live with their feet planted firmly on the floor during their 6-month transit. But the HAB is not entirely alone on its journey. Just ahead of it is a second ERV, identical to the first. Launched just a few weeks prior to the HAB, it will prepare the way for a second human crew that will follow 2 years later. It can also function as a backup for the first mission, if anything should go wrong. On the 6th month of the flight, the crew will gaze upon an alien world. This is the new frontier.
Oh, spectacular. Just spectacular.
After days in orbit and satisfied with the landing conditions, the crew will receive final word from Mission Control on Earth.
All systems are go for entry, descent, and landing. 3, 2, 1.
It will be a tense 40 minutes before people back on Earth get the signal from Mars and know if everything has gone well.
Okay, 75 feet. Car's looking good, down a half. 6 forward. 60 seconds. Lights on. Forward. Forward. 40 feet down, 2.5. Big shadow. 4 forward, drift into the right a little. 30 seconds forward. Contact light. Okay, engine stop.
We're seeing it on the LTP. We're on Mars, everybody.
For more than 500 days, the astronauts will live on Mars and embark on one of the greatest journeys of discovery in the history of science. Will they find life? Or the fossilized remains of past life? Such a discovery could tell us whether our solar system has seen more than one genesis, and answer the ultimate question: are we alone? In any case, these explorers will be learning how feasible the colonization of Mars really is, and whether or not mankind has a future among the stars. Then, when the time comes and the window for Earth return opens, the crew will climb into their Earth return vehicle and head home. They will arrive home heroes, the first to stretch the limit of man's expanse from one planet to another, their names added to the list of great explorers of new worlds. In their footsteps, others will follow. What began as a trickle is free to rise into a deluge of humankind, sweeping over a once barren land and transforming it into a viable new world. When Baker and Zubrin presented Mars Direct to their bosses at Martin, they expected the worst. To their surprise, management was excited about it. They liked the fact that everything needed was relatively simple and near-term.
As time went on, Martin Marietta embraced Mars Direct as their creation and put Bob and I on an airplane to several NASA centers to present Mars Direct and try to build some momentum for it.
Baker and Zubrin flew to the Marshall Space Flight Center in Huntsville, Alabama. This had been one of the original design hubs for the Apollo moon landings, but recently many of the engineers had become demoralized by the failure of NASA's SEI program. Tag team style, Baker and Zubrin presented their alternative mission architecture. The response was thrilling. The old-school Apollo crowd embraced it. This was a plan that actually made sense and was within reach.
Baker and I gave a number of briefings. The first was at the Marshall Space Flight Center. Next was at Johnson. These people were incredibly excited.
Over the next few weeks, Zubrin and Baker were flown around the country, pitching to all branches of NASA. And everywhere they went, the response was electric. The plan was standing up to scrutiny, and groups all over NASA were converting to Mars Direct. Their tour culminated in a public presentation to the National Space Society. The crowd gave the two aerospace engineers a standing ovation. A week later, the story was in newspapers around the country. But a counterattack was beginning to form within NASA. The space station teams and many in the advanced propulsion groups were against the idea. Since Mars Direct didn't need their programs, they felt under threat. As quickly as doors opened for Zubrin and Baker, they began to close.
NASA didn't want to pursue a Mars mission at that time. They didn't want to be derailed by a bunch of Mars fanatics that thought that their idea of what NASA should do should overwhelm what NASA thought NASA should do.
What we did in Mars Direct was literally come up with the leanest solution, the one that involved the least spending on an assortment of technologies and infrastructural elements, including, for example, we made no use whatsoever of the International Space Station. And so people involved in all those programs were very upset because we were showing that you could go to Mars without their program being required. And they felt that we were de-justifying them.
The NASA administration rejected Mars Direct. The two engineers were outsiders again. But Zubrin remained determined.
Bob had grabbed hold of it, and I could see that it was his, and no matter what I did, he was going to do what he was going to do, and he was going to be a proponent for it and push it, and I really saw my role sort of evaporate. It's a little bit like being a dim planet next to a bright star around him in terms of his enthusiasm, and you really can't compete with that. All you can do is decide how you're going to deal with it.
By February 1991, Baker quit Martin to start his own firm. Zubrin battled on. For the next year and a half, Zubrin tried to get NASA to pay attention, giving speeches, writing papers, but Mars Direct's time seemed to have passed.
But then in 1992, a new administration came into power at NASA, and Zubrin saw a second chance.
I was invited to brief Mike Griffin, who was the Associate Administrator for Space Exploration in charge of the whole Space Exploration Initiative. He immediately became a very strong supporter of Mars Direct.
But before the engineers at NASA would take another look at Mars Direct, they wanted Zubrin to prove that producing rocket fuel on Mars could work. They gave Martin Marietta a small budget to do an experiment. Zubrin and his team built a machine called the In Situ Propellant Plant. It could take carbon dioxide, the dominant gas in the Martian atmosphere, combine it with a little hydrogen, and produce a methane-oxygen fuel.
We did it in 3 months with a very small team. We built a plant that was 94% efficient, and no one who actually participated in that effort was actually a real chemical engineer. They were all aerospace engineers, like me, who were simply dabbling in chemistry in order to prove to NASA that 19th century chemical engineering really worked.
With the experiment a success, the administration had Zubrin give detailed briefings of the mission plan to the engineers at the Johnson Space Center. They liked it, but had some problems. Dave Weaver was the lead mission architect.
There were a number of things that we were concerned about with Bob Zubrin's mission. First of all, we thought his estimates of mass were probably too optimistic. Didn't have sufficient margins for a variety of things, not the least of which would be things like provisions for the crew, the amount of water that would be required. We thought his ascent vehicle was very large, which meant his power requirements, his propellant requirements were much larger than needed to be. His trip times out were too long, and that for very little effort you could get them shorter. The other problem was the size of his crew. He had a 4-person crew. I think virtually every study that's been done says that a 4-person crew for a 3-year type of mission is probably not realistic.
Weaver took Zubrin into his office, and the two men worked out compromise mission architecture. First, Weaver wanted 3 launches for every mission instead of 2. The first year, 3 ships would launch: a MAV, Mars Ascent Vehicle, an unoccupied HAB, and an ERV, Earth Return Vehicle. The HAB and MAV would land on the surface and begin producing fuel for the return flight and air for the crew. These craft would spend 2 solitary years on Mars, allowing NASA to test all of the systems before sending a human crew. Then, in the 3rd year, 3 more ships would launch, this time with the HAB occupied by astronauts. The other 2 ships are for a future mission, unless needed as a backup for this crew. Once on Mars, the team could also utilize the first HAB. Then, after a 1.5-year stay, the crew would climb aboard their small capsule and rendezvous with the return ship. This ship would carry them back home in a roomier environment than Zubrin's ERV. Zubrin called the plan Mars Semi-Direct. NASA called it the Design Reference Mission.
They had a larger crew than we had. They had bigger ships. They had more equipment. They had heavier equipment. So they had to do the mission in 3 launches instead of 2, but it was done with the same principles of Mars Direct.
The plan was subjected to the same cost analysis that tagged the 90-day report with a $450 billion price tag. The Design Reference Mission came back at a fraction of the cost, $55 billion. Spread out over 10 years, it could be done within NASA's existing budget. The plan made the cover of Newsweek. Here was a mission architecture that was affordable and could be done today with existing technology. But NASA's astronauts have not left low Earth orbit since.
With the completion of the International Space Station and the retiring of the Space Shuttle program, a debate rages over the future of space exploration.
Should NASA continue to focus on low Earth orbit, developing technologies for the future? Or should NASA have a goal, like it did in the 1960s with Apollo?
The way we got to the moon was by a presidential imperative that demanded that NASA get to the moon within a decade. So NASA was forced to sit down, design a plan for how to do that, and then fly the mission. Since that time, without the presence of a driving imperative, we engage in basically a random set of constituency-driven programs which are justified ad hoc afterwards by the argument that they could prove useful at some time in the future when you actually have a plan to go somewhere.
I think NASA has focused on a steady process where the government can't just pull the plug on their funding. I think the Apollo cancellation was very traumatic for NASA, and it really transformed NASA from what it was in the 60s to more of what it is now. If you have a singular program like going to Mars, then it is very vulnerable to having its funding pulled.
NASA must be destination-driven. It is the only thing that allows the agency to be productive. NASA was 100 times more productive when it was destination-driven than in the period that it has not been. And we have stagnated in NASA since 1973. 30 years, more than a generation, has been wasted. The American space program's been stagnant for 30 years. There's a once-in-a-generation shot right now to get it moving again by giving it a goal that'll take it somewhere. So the stakes today are high. And if you ask me if I am nervous right now, I am.
Dr. Zubrin.
Why is NASA stuck in low Earth orbit? The problem with NASA's lack of current achievement is not money. The problem is lack of focus, it's lack of a goal. It shouldn't be humans to Mars in 50 years. It should be humans to Mars in 10. We can do this. We do not need gigantic nuclear electric spaceships to send people to Mars. That is pork, it's nonsense. The primary question I get from the American people is, why aren't we doing this? There's a big sense of disappointment, almost verging on a sense of betrayal. The purpose of spaceships is to actually travel across space and go to new worlds, not to hang out in space and observe the health effects from doing so.
Dr. Zubrin, in your testimony, you were very passionate on it, but you also were mad. You're mad we haven't done this, or that this vision has been stolen from a generation?
I guess you could say that. It's like Columbus coming back from the New World and Ferdinand and Isabella saying, so what, forget it, burn the ships. Okay, you know, that's what has happened in this country. We've won our point that there needs to be a destination. What we need, the point we need to win on now is that the destination needs to be Mars, and it needs to be soon.
The movement to send humans to Mars in the near term began at the University of Colorado in 1978. A graduate student in astrogeophysics named Chris McKay gave a small seminar on the possibility of introducing life to Mars.
I got interested in Mars in graduate school. I entered graduate school the same year that Viking landed on Mars and sent back these images, and it sent back data that showed all the elements needed for life are here on this planet, and yet there's no life here. I thought, oh, that's odd. It's sort of the lights are on and nobody's home. And I thought, well, that's curious. So some of my other grad students and I, we sort of got together to talk about, well, if there's no life on Mars now, could we put life there? And that evolved also into the question was, maybe there was life in the past, and so we could find fossils, evidence of it. Well, how would you do that? Well, you do that by sending people there.
Together with fellow graduate students, the group decided to put together a small conference to discuss the matter of human Mars exploration.
We basically just started a forum. We invited everybody from all the NASA centers and from all the universities that were involved in it, and they all came. And it really was, in retrospect, I realized a very important step toward building a consensus for human exploration of Mars.
In 1996, I published my first book, The Case for Mars, and the response was phenomenal. I got 4,000 letters from all over the world. I had Parisian bankers and 12-year-old kids in Poland and firemen from Saskatoon and astronauts, and they're all writing me and saying, how do we make this happen?
Bob Zubrin came to the third Mars conference and got very much involved. And he was willing and interested in forming a society, forming a group and organizing.
He said, look, if we could pull these people together, if we can get them to work together, we could have a force that could actually make humans to Mars happen.
The group formed the Mars Society. Robert Zubrin became the president. They held their first convention in 1998.
The convention was just magic. We had no idea how many people were coming. They were there not just from the United States and Canada and Europe. They were there from Israel. They were there from Mozambique. They were there from New Zealand. It was astonishing.
Since its inception, the Mars Society has attracted members worldwide.
Derek Shannon is the head of the Southern California chapter. He's met with political leaders from all over the country.
If you make them look at the whole Mars vision in historical terms, it becomes a much easier sell. How will the Martians remember our century? They're probably not going to remember our deficit, our wars, our healthcare. Those will be footnotes. What they'll remember is that out of all of human history, there came a generation that decided to take this amazing step out into space. And if you tell politicians that they're the ones whose names actually get to be remembered, that's when, hopefully, the space program starts going somewhere.
In order to further the knowledge necessary for a manned mission to the Red Planet, the Mars Society has been building research stations around the globe, all of them based on the design of Zubrin's HAB module. Most recently, the Society set up a desert research station in Utah. Here, international researchers and aerospace students come to do experiments under the harsh desert conditions and learn what's necessary to keep a Mars crew alive and productive.
Basically, what we're doing here is undergoing analogue studies. Crews of up to 6 people at a time come together to live in a full simulation environment for up to 14 days. So what that means is every time we go outside the HAB, people have to don spacesuits, they have to depressurize. When we go outside, they're called extravehicular activities. They can only be of a certain duration due to the air supply. We have to recycle all our water and basically have our own food as well.
It's great to fantasize, but it's another thing when you have to put it together, when the nuts have to fit the bolts.
Like the Apollo missions to the Moon, sending human beings to Mars will mean putting people in harm's way. There are many dangers in outer space, and many things could go wrong. A serious equipment breakdown could doom the crew to their deaths. Some argue that the risk of failure is simply too high.
You know, back in the days when medieval man was looking out from Europe and thinking about exploring the world was unknown, and map makers populated their maps with dragons. We've got the same thing today. There are people who are afraid to go out into space, and they've populated their maps of the solar system with dragons. You know, we've got cosmic radiation, we've got zero gravity, we've got back contamination. But these are dragons that we can take on.
There are two kinds of radiation astronauts must contend with in outer space: solar flares and cosmic rays. Solar flares are floods of protons that burst from the sun at irregular intervals and would be dangerous to an unshielded human crew.
We are not ready to send humans to Mars right now. We've got to know a lot more about radiation and radiation mitigation. One of the Apollo flights barely missed, like by a week, a major solar event. If it had gone off when the Apollo astronauts were on the way back and forth to the moon, they would have gotten their entire lifetime radiation dose in that one mission. And that's just one solar flare. So that's why we worry about this.
In the Mars Direct plan, Zubrin envisions a central insulated core where a crew can retreat to while the radiation passes by. The core would be surrounded by all the provisions of the mission. This should stop any harmful dose of radiation from reaching the astronauts.
Basically, you use your pantry as your storm shelter. So a solar flare happens, the alarm bell rings, the crew goes into the storm shelter, they stay in there cramped up pretty tight for a few hours until the all clear rings and they come out. This is going to happen once, it might happen twice in the course of the mission.
The second type of radiation is cosmic rays. This constant rain of charged particles comes from interstellar space and cannot be avoided without many meters of shielding. We can experience some of this type of radiation on Earth at high altitudes. Airline pilots who spend their careers flying high in the atmosphere can receive almost as much of this radiation throughout their life as a Mars astronaut would on a 2.5-year mission.
It's a long trip. It's a 6-month trip there, a 6-month trip back. It's probably a year on the surface. That's a lot of radiation.
The best estimates are that the magnitude of that dose is not that great, perhaps 60 rem of radiation scattered over 2.5 years. Now, 60 rem of radiation delivered over a long period of time like that would not create any noticeable effects at all. It would, though it is believed, increase your statistical risk of getting cancer at some point later in your life by about 1%. Right now, if you're an average American and you do not smoke, you have a 20% chance you're going to die of cancer. This would make it 21. If you're an average American smoker, it's 40. So in fact, if you recruited the Mars crew out of smokers and sent them to Mars without their tobacco, you would be reducing their chance of getting cancer.
With the immense distance from Earth, never before experienced by a human being, with the constant dangers of outer space surrounding their small, life-sustaining craft, and with nowhere else to go, the psychological impact on a crew could be severe.
Fear is real. I mean, it would be, to me, abnormal for a person to not feel the fear of getting on a rocket and launching into space and going to Mars. So I think fear is a very normal thing that all astronauts, in fact, are supposed to have. And I would be afraid to fly with someone who does not have fear.
Some psychologists worry that cabin fever could set in, and the crew might literally go crazy.
The human Mars mission is a more rigorous and difficult condition than most of us experience in daily life. But it is hardly a more difficult situation than many people have endured throughout human history. We could compare the Mars crew to the crew of 19th century or prior sailing vessels, many of whom were away from home for 3 years or more than 3 years, under conditions in which they're eating extremely bad food, without any medical knowledge to support their health, commanded by brutal officers. In every respect, the crew of a human Mars mission, with the full support of mission support and the whole world cheering for them and great rewards awaiting for them in life upon their return, is in a vastly superior condition.
The Mars Direct crew will spend most of their time inside the 2-story hab, carefully designed to promote psychological well-being despite the confinement.
The space where I think everybody would spend the most time, just like a lot of homes on Earth, would be the galley wardroom area. There would be chairs, a table, some kind of large screen for entertainment. You would have individual staterooms about 4 or 5 feet wide. The ability for them to communicate with loved ones, with colleagues on Earth, I think will be almost unlimited.
A Mars crew will need to be carefully chosen and thoroughly tested to ensure their ability to handle the extreme isolation.
Wow, what a place. What a view, isn't it, John? It's absolutely unreal.
John Young, who went to the moon, used to say that he could cover the Earth by just lifting his thumb up to it. And he says that when you go to Mars, you are going to redefine the concept of loneliness. And so it is very important that the crew be well balanced and well chosen so that they can support each other.
Whoever gets picked to go, they will have to learn to live together for 2.5 years.
If you put out a call for volunteers for the first crew to Mars, they'd be lined up coast to coast. Most people recognize what's left after you go is the good you left behind. And to take part in an adventure of this character, of such a historic character, of extending the reach of the human species, this is something of immortal significance. One of the most bogus threats associated with the Mars mission is the so-called back contamination issue, which is this notion that you go to Mars and discover these virulent disease organisms that you bring back to Earth and destroy all life on Earth.
If we discover life on Mars, One fear is that our Earth biology will have no defense against possible Martian pathogens. Some argue that missions to Mars cannot be risked until we can prove Mars is free from harmful contaminants.
This is completely nonsensical. There's natural transfer of material from Mars to Earth all the time. We get around 500 kilograms of unsterilized Martian rocks landing on Earth every year, and they have been doing so for the past 3-4 billion years. And so if there were Martian organisms that could contaminate the Earth, they've already done so.
Although the prospect of Martian diseases seems remote, lawmakers have required that NASA create elaborate protocol to ensure that any extraterrestrial material stays contained. And like the Apollo astronauts, who spent 17 days in quarantine after their return from a sterile moon, the Mars crew will have to be thoroughly tested for any harmful Martian pathogens.
The probability is infinitesimally tiny. But nevertheless, this is our home planet and it's extremely important and we have to protect it.
The idea of a pathogen on Mars is clearly ridiculous because there is no megafauna or megaflora on Mars for pathogens to infect. So it is impossible to propose a credible life cycle for a Martian pathogen. The diseases that afflict us have been co-evolving with us and our ancestors and near relatives for the past 3 billion years, and they are specifically designed to live inside the habitat of the human body and to overcome its defenses, and they've been engaged in an arms race with the human defenses for those 3 billion years. This is why humans do not get diseases from distantly related species. For example, I don't know of any person who has ever contracted Dutch elm disease, and trees don't get colds.
When the first Mars lander touches down, the crew will be staring out at a new world, a place that in 4 billion years, no eyes have ever seen. The crew won't be alone. Millions of television viewers back home will be watching as the first man or woman places their footprint into the rust-colored soil. The crew will savor these moments, for here, someday, a new branch of civilization might begin, and future Martians will remember and celebrate this day. There is much for the crew to do and explore. One of their main mission objectives will be to search for signs of microscopic life. To do this, they will follow the ancient water flows. For on Earth, where there is water, there is life. To help the crew in their search, they will have a pressurized rover that allows them to explore in a comfortable shirt-sleeve environment. This means the crew can examine a vast area around the landing site during their 18-month stay. And there is much to explore. Mars has 58 different kinds of topography and a surface area equivalent to all the continents of Earth combined. If these explorers can uncover the fossilized remnants of indigenous Martian life, they will redefine mankind's understanding of its place in the universe.
For if life arose separately on a planet so close to our own, it strongly suggests that the universe is a biologically rich place and full of life. For some, the ultimate question of Mars, though, is will there be human settlements on the planet? Will Mars become a new branch of human civilization?
As each subsequent Mars mission explores a wider and wider area of the planet over several years, an ideal site for a base will be found. probably one with a thermal vent that can supply water and power. At that point, several HABs will be landed in this one spot, with crews that plan to stay for 4, 8, or even 12 years. The HABs will be interconnected, and a permanent human presence on Mars will be established. This scientific community will have to learn to become self-sufficient, to be able to survive on Mars without supplies constantly being sent from Earth. But unlike any other planet in the solar system besides Earth, Mars has all of the fundamentals needed to make this possible. Its 24-hour and 37-minute day is critical for growing plants. It has all of the elements necessary for creating building materials like plastics, metals, and glass. And it has oceans of water frozen into the soil.
If we can develop this craft of living on Mars, then Mars becomes inhabitable. Not immediately physically, but intellectually. I mean, look, what determines whether an environment is habitable or not? Is Colorado habitable? We're not naturally adapted to live in Colorado. We're tropical animals. No one could survive a single winter night here without technology, such as clothing, efficient use of fire. We invented our way into becoming people that could colonize such hostile environments.
Eventually, with a lot of ingenuity and invention, the scientists will learn to live off the land. They will grow crops in the iron-rich but potassium-poor soil. And they will produce oxygen and energy from the water and atmosphere. Sooner or later, children will be born, the first true Martians. They will grow up to see Mars as their home. With time, more and more people will arrive. These won't only be scientists, but settlers, people who plan to stay. They may come for all kinds of reasons, but to them, Mars will be a chance to start over, to build a new life for themselves.
The well of human social thought is not exhausted by the present age, and I don't think will ever be exhausted. There will always be people with new ideas on how humans should live together.
With Mars so far away, the hold of Earth governments on their colonies will be tenuous. The Martians will need to govern themselves.
Mars is not going to be a utopia. Mars is going to be a lab. It's an open frontier. It's a place where things are going to be tried out. I think we'll see a lot of noble experiments on Mars. Perhaps some of these Martian colonies with their novel ideas based on the best thought the 21st century has to offer, maybe they'll find ways in which humans create society that are more humane and offer more opportunity for human potential.
The ultimate dream of the Martians will be to terraform their planet, to make Mars as hospitable as Earth. This may not be as big a fantasy as it seems.
Here we are on Earth, a world that's very sophisticated and developed and complete. And anything we do is just a subtraction. It's because we live in such a biologically rich planet. When we go to Mars, we have an opportunity that we don't have on Earth. Here's a planet that's died. Here's a world that's not full of biology, probably doesn't have any at all. Well, there, we can actually do something to help.
Once there are large human settlements on Mars that will have significant industrial capability, we could actually start addressing ourselves to the question of transforming the Martian environment itself, terraforming Mars, as it's called, because Mars was once a warm and wet planet, and it could be made so again through human engineering efforts.
With daytime temperatures in the Martian tropical zone averaging around 0 degrees centigrade, and with an atmosphere only 1% as thick as Earth's, exposure to these elements by a human without a spacesuit would be instantly fatal. The first step to terraforming Mars and bringing it back to life will be for the Martian colonists to warm up their planet.
Well, we know how to warm up planets. We're doing it on Earth. by putting gases in the atmosphere. On Earth, it's not a good idea to warm up the planet. The temperature was just fine, thank you. We don't need it any warmer here. But in principle, if you could trap the sunlight reaching Mars today, every single photon that's hitting Mars, Mars would warm up in about 10 years. Well, obviously you can't trap every single photon that's hitting Mars, but you can trap about 10% of them with the greenhouse effect. So that would imply that Mars could warm up in about 100 years. Well, 100 years is a long time, but it's not astronomically long.
One idea is to build small, automated factories that produce super greenhouse gases with no ozone-depleting side effects. Although these gases would be unwelcome on Earth, for the Martians they would be an efficient way to trap heat.
Then within a few decades, we would raise Mars by more than 10 degrees centigrade. And if you did that, that would cause massive amounts of carbon dioxide that is currently absorbed into the Martian soil to start to outgas.
Carbon dioxide is also a natural greenhouse gas. As it builds up in the atmosphere, more and more heat will be trapped, which will in turn cause more CO2 to outgas. The process will become automatic, and as the atmosphere thickens, Mars will eventually reach a state of equilibrium and stay warm naturally. The rise in air pressure would mean that the human colonists could discard their pressure suits and walk around the surface of Mars carrying only a supply of oxygen. And as the temperatures rise on Mars, water frozen into the soil will begin to melt out. And for the second time in its history, Mars would have liquid water on its surface. Dry Martian rivers will start to flow. Seas will rise, and there will be rain clouds in the skies. The return of Mars to its warm and wet stage will make it a fertile environment for life. Any indigenous Martian organisms lying dormant will begin to grow, and Mars will be full of Martians. If no native life emerges, or that life is all dead, then humans could begin addressing the idea of bringing life from Earth. At first, it would be simple organisms, perhaps genetically engineered, that would thrive in the Martian environment. Then more complex plants could be introduced. The plants would be right at home in the carbon dioxide atmosphere, and with no competition and a whole planet to cover, they could transform Mars into a green world. Warming Mars so that it sustains life is rapid, but then the slow process of making the atmosphere breathable for humans and animals starts, and that's done by plants. Although the process will happen naturally, if the colonists can't find a quicker way, it will take tens of thousands of years.
This is a philosophical debate. Many people think the universe has a big sign on it that says, "Do not touch. Leave it alone. It was made this way. It is not in our purview as human beings to change anything." I can respect that view, although I disagree with it. I think the universe has a big sign on it that says, "Go forth and spread life." Because when I look around the universe, I think life is the most amazing thing we see. It is just incredible. And we human beings are uniquely positioned to help spread life from this little tiny planet, which it seems to have been started on, beyond. And that's our gift. Earth's gift to the universe, I think, is the gift of life.
This scheme for terraforming Mars is based on 20th century notions of engineering. I don't think it is how Mars will actually be terraformed. What you have here is a 20th century mind trying to address a 22nd century problem. And so I think Mars will be terraformed by the 23rd century, not by the 33rd, by the 23rd. Things that would seem utterly fantastical to us is how it will actually be done, but it'll be done. We're at a crossroads today. We either muster the courage to go or we risk the possibility of stagnation and decay.
The exploration of the solar system and expanding of life through the rest of our solar system and someday beyond is the kind of thing that will keep our civilization going.
We're explorers by nature. Eventually we will go to the stars. And the question is, when will we start?
I think a man-Mars mission could happen within 15 years.
Some days I'm very optimistic. I think we can do it in 10, maybe 15 years. Other days I see all the political things that go into the space program. I look back on the 30 years we've been bogged down, and I get more negative about it, and I say it's going to be another 3 decades or 4 decades.
I would be surprised if we got to Mars prior to 2025 or 2030.
In May of 2018.
Understanding the various political obstacles that exist and what we need to fight through to get the program started, I believe that we will be on Mars by 2020. You have to believe in hope. You have to believe in the future. There are more and more people coming around to the point of view that a positive future for humanity requires human expansion into space. We will eventually break through the forces of inertia that have been holding this thing back.